Here's question number 120. A skydiver flying over the jump area is about to do two things: jump out of the plane and pull the ripcord. Are the two events, jump out of the plane and pull the ripcord, commutative? Well, let's start by reminding ourselves what the commutative property is. On page 115, your textbook defines the commutative properties of addition and multiplication by saying that changing the order of the numbers will not change the result. So if changing the two events, jump out of the plane and pull the ripcord, does not change the result, then the two events are commutative. Two different events. Jumping out of the plane is one event, and pulling the ripcord is another event. So we're not talking about changing the order of the numbers, we're talking about changing the order of the events. Does changing the order of the events change the result? If not, if changing the order does not change the result, then the events are commutative. If changing the order of the events does change the result, then the events are not commutative. While changing the order of the events, jump out of the plane and pull the ripcord, means that they're done in a different order. If we jump out of the plane first and then pull the ripcord, things should work as they're meant to. But if we pull the ripcord first and then jump out of the plane, things could get messy. Jumping out of the plane and pulling the ripcord are not commutative events. Here's question 122. Simplify the expression 10 minus 5 minus 2 and the expression 10 minus 5 minus 2 to show that subtraction is not an associative operation. The first expression, 10 minus 5 minus 2, must be done in the order 5 minus 2, because it's inside parentheses. 10 minus 3 is 7. The second expression, 10 minus 5 minus 2, must be done in the order 10 minus 5 first, because it's in parentheses. Minus 2 and 5 minus 2 is 3. We get different answers. By the associative property, it seems like since all my numbers are in the same order and all my signs are the same, since all I've done is move the parentheses, I should get the same answer. But because of the order of operations, I have to do this subtraction first and subtract the result from 10. In the second example, I have to do this subtraction first and then subtract 2 from that result. In fact, what's actually happening here is I could pretend there was an invisible 1 in front of my parentheses. And then if I pretend my 10 is invisible, just for a moment, what I'm looking at now is a case of distribution. I need to distribute the number -1 across the sum 5 plus -2. I won't go into any more detail about that here because it's really a topic for another lesson. But suffice it to say, because I'm subtracting all of this from 10, I can't just change the order I do my subtraction in. Subtraction is not an associative operation. In question 121, instead of asking you to do two division problems, the question asks you to give an example that shows that division is not a commutative operation. Here we've been working with the idea that subtraction may or may not be associative. You're going to be working with the idea that division may or may not be commutative. So make sure you get the right property, first of all. And then instead of giving you two problems and asking you to do the two problems to show that division is not commutative. The question asks for you to give an example. In other words, you come up with a division problem and another division problem, which, although they have the same numbers in them, when you commute the numbers, you don't get the same answer. That's it for section 1.5. We've made it all the way through, all the lectures, and all the worked examples. Please feel free to send me a WAMAP message or an email if you're having any trouble. See you in the next section.